is the YouTube channel. I guess I can check too. Let's do a little bit of meta here. Comp
Let's see.
YouTube. Search comp digital 42. No results. Well, that's not good. Let's see.
What's like the YouTube URL for
I don't know the URL. Does it say?
an account? Here, I'll look it up.
Definitely some. There's like the chat and everything, so it's definitely like live right now. The chat is
Okay, cool.
Yeah, it's got to be because the chat is there in this tool, but I don't see it, so I'm trying to do this.
Is that the name of the channel? Comp Digital 42?
Yeah, digital.
Yeah, we couldn't think of. We're not very creative.
On the spot.
No, that's fine. It's just I think you have to search for channels.
How do you do that?
That's a good. I don't remember. Hold on, I'm trying it.
Oh wait, what?
All one word.
What? Yeah.
Comp Digital 42.
Well, I'm not gonna say the password because we're streaming to YouTube right now.
Streaming 101. Don't give out any authentication.
Yeah, right. It's live, man. I can see it. It's on the thing. It's
All right. Well, we'll find it
right now?
afterwards.
Cool.
Yeah, it's live.
You can when you go on YouTube.
I can send you guys the link.
Yeah. Why don't you just send the link and then we can just see it that way.
You should. There's a link.
No.
Streaming
Share the
101.
link.
Don't give out
There's no link. I had to find this.
any authentication.
Yeah, right. It's live, man. I can see it. It's on the thing.
All right. Well, we'll
Here, let me put it in the chat. Right here. So there's the link to the video. I'm gonna use the bathroom. I'll be right back, guys.
Okay.
Oh, here we go.
I'm just getting us set up, like in the sections.
But I'm hearing myself
I
talk.
see
What's
it.
going on?
You see the screen? Is it too small? All right.
Oh, I hear myself too. It's a little. There's a lag, I think, in the stream.
Yeah. I think there is. We're hearing our conversation from like 30 seconds ago or a minute ago.
We're in the future.
It's a little eerie.
Alright. So what am I even sharing right now?
What am I listening to? John?
Yeah, it's hard to tell if it's real time, right? So John, there's like a 30-second lag or something. So like we're hearing our conversations from before. So I didn't know if you were actually speaking like
Yeah, I thought you went
real
to the
time.
bathroom.
Wait. So there's a 30-second lag?
At least when I went to the
So you shouldn't look at it.
I think there might be reasons for that.
Yeah.
Legal reasons for that. But that's okay. That's fine. So I think.
Okay, you want me to start?
Yeah. Like, I'm gonna try to get as good at this as I can. But basically, I have two monitors, and I'm recording the stream on the Hangouts monitor, which I have all you guys on. So I'll probably just, depending on who's sharing or what we're talking about, I'll probably click on the different Hangout stuff. But I have stuff on my other screen. So I'm sharing in Hangouts my other screen, while I'm streaming the Hangouts screen. So hopefully that
Okay.
makes some sense.
All right.
Yeah, that's fine.
All right, cool. I know I'm pouring myself a King Su beer because after what I just did, went
You deserve a reward.
Yeah. That's
We've only been trying to figure it out for
oh
three
no,
That-
not because of
chapters.
this. I'm not that pathetic. But all right.
So this chapter is on clustering and k-means.
Yeah. So
So I don't know if you guys got it, but basically the optimal solution for any cluster assignment follows this J-clust formula, which is basically all of the distances, the average of all of the distances from their centroid.
yep. And then they split up JClust into like each index, so you could do it for each particular cluster as well, like
Yeah,
J1, J2, and then
So,
obviously JClust is the summation of all those.
can we just like
Yeah.
before we get into the Julia thing, can we just pull up the book a little bit?
Okay, yeah, that's
Just
fine.
because like we just to clarify everything on the J cluster, k-mean stuff. I can pull up the book if you want.
Can you guys see?
Okay.
I
I
you
got
guys
it
can see
right
my
here.
screen?
Yeah, that's perfect.
So
yeah.
yeah.
Okay.
So J-clust, let me see if I can scroll back to the formula.
So wait, who's sparked? Is that you?
That's
Shane?
me.
Okay, so you got the book. All right, cool. So this is just going over like what before we
So-
get into the Julia stuff, what it's really going on.
All right. So JClust here equals the distance between each individual vector and their leader, which is the centroid, and the sum of squares of that, and then
Okay.
divided by
okay,
n.
Wait. So the leader centroid isn't a real. So wait, this is the leader.
Yeah.
This is the leader. Okay.
The
so
Z-
it's not-
Z is
it's
the
not
leader.
K-means, right? This is the. Wait, what is? Can you go back up for a sec? Like the first time they introduced. Yeah, what's
Yes,
that
so that-
purpose? I don't even know it.
That's this is 4.2.
Go to page 73.
Yeah.
73 has it. It's right there. So basically, I think it's the norm. It's the norm of the difference between the x vector, which is your data point, and its centroid.
Yeah.
And then it adds them all together and calculates the average.
Yeah, that's k-means.
So-
but is this even?
I think
No. Both k-means and k-nearest neighbor, which is like the inefficient calculation, all use this J-clust. This is J-clust right here. It's the
Right,
same
no,
for
no,
K.
I
It's the
understand.
same for all of them.
Yeah, I understand that, but like the difference between k-means and other things is like in the case of when there's z vectors, like in k-means, it's like a hypothetical centroid. It's not an existing
Yeah.
point on the
The Z-
at
the-
a vector space.
yeah.
Yes,
The
exactly.
leader
But that's
the
not-
leader
that's
can
only
be
the case for
different.
K-means. That's not the case for other things. So that's why I'm trying to figure out what.
But you-
Yeah, what it
section
goes
I'm
through
looking
in the
at here.
book is it has you can move the centroids around and then try to minimize the difference by moving them around, or you can
Right, but
what's the
K-means is
second thing
only
that
one
you can
that's
change?
Dealing with centroids. The other stuff doesn't
So-
even have centroids. Is what I'm trying to say.
Oh, okay. So
Okay.
maybe my terminology when in the beginning when I said the distance between x and the centroid,
That's
I
why I'm
really
saying-
just meant
that's why I'm
I just
trying to
meant
figure out
leader.
What I'm looking at here, like what's
Yeah.
even in? Because
So we're in the very beginning
right.
before it even introduced
Right.
K
So-
means.
So Z, what is Z? Z is a representative vector associated with that, and how do you
To that
choose-
group.
And how do you choose Z? I think is what they're talking.
Yeah.
I'm trying to figure out.
So
here.
I don't so I don't think
like K means is you're finding centroids,
Yeah.
and then you're finding the distance of the centroids. But in this case, yeah. So okay.
so I think this is just like a theoretical formula, saying we want to try and minimize J clust, but they don't they haven't chosen Z. They haven't got at this point in the text 4.2. They haven't shown us methods of how to
Okay.
choose Z.
So Z could be, in the k-means, Z could be a centroid. That's fine. There's no problem with that.
Yeah.
I'm just saying, like, it's not a guarantee that it is the centroid.
That's not what it means here.
It's
Yeah.
just some leader representative of a group, of a
Yeah.
cluster group.
Yeah.
And
Yes,
Yeah.
but getting into what they get into in, I have in my part E in my notes, what they're saying is Z is always the representative. They call it the representative from the beginning.
Yeah.
And those representatives are like some centroid of the
no, but
thing.
they're not.
And you can
That's
either
what I'm
keep
trying to say.
those
They're not a
fixed,
centroid. Like, they
or you can
be.
vary them.
They can be if that's your clustering algorithm, but like in like
Yeah, I agree.
Yeah.
There's other
That
clustering algorithms.
Yeah, on some of the stuff that Ryan and I have done on graph stuff, the way you do like these different graph algorithms, clustering methods and stuff like that is you arbitrarily assign a group leader and you add edges into the cluster, into the spanning tree, and like it's basically a bunch of pointers to the group leader. Yes, in k-means, that group leader vector is a centroid space, but it doesn't have to be.
It doesn't have to be a
Yeah.
centroid.
Because
So,
the centroid, the
wha-
problem with the centroid is, or not even a problem, is it doesn't actually exist, right? It's not in your data set. It's just a center of your data set.
Yeah. So 2 points when they first introduced Z just as a representative, they did mention that Z just has to be the same length as X, the same number of dimensions, but it's theoretical and it can be any.
Okay.
Right.
Right.
They did mention that. So it's a theoretical. It could be any combination.
To k-means, they just
Yeah.
arbitrarily assign it. I'm pretty sure they
Yeah.
literally pick one from the. I think that's what our next section.
That's
is.
called initialization.
Yeah.
That process is because what happens when you run any clustering algorithms is you have to initialize where you start them, and then they move around
Right.
while you run it.
Yeah. One other point that I think might be important is that yes, it's the norm of the difference. I believe that the norm of the difference is also by definition the distance between two vectors.
Yeah, it's the Euclidean distance.
So it is. So we're taking the sum of squared of the distance between each x value and their associated representative.
Well, it's the order
And
of
then-
magnitude of the distance of the. Well, it's the same thing.
Yeah, it's Euclidean distance squared. essentially.
Yeah, I think when they first introduced it, they said it's could be you can call it magnitude, you can call it distance. I think both of those words are I'm pretty sure
Yeah.
are correct.
Right.
What you'll see with other clustering algorithms, like there's k-means, nearest neighbor, stuff like that, is they use other measurements of distance other than Euclidean distance. That's what you'll see with a lot of them. Some of them will use eigenvectors, like when you get into spectral clustering. So like if your data is like a circle and then a circle inside of a circle, and you want those two circles to be clusters, you have to use like spectral clustering and other types of clustering.
So it looks like, so this part that you have right here, Shade. These are the important sections that I just kind of wanted to highlight before we got crazy. So
Okay.
before we even get up to k-means, like the naive thing is to fix. So this one's going to assign. This is going to wait. What is this one? This is a fixing assignments. What is it saying? The problem of choosing group
The
representatives.
assignment, like what group is it in?
Yeah. But so it's this one's approach is finding the optimal group representatives with fixed assignments. The next one
Yes.
is finding the optimal assignments from fixed group representatives.
Yes, and k-means alternates between
Representative,
doing those
yeah.
two
K-means
things.
alternates between the two.
Yeah.
Exactly.
It says do the first one, do the second one, do the first one,
Right.
do
Yeah.
the second one.
Right.
Yeah.
And it's actually like, I know that sounds a little wordy, but it's like very kind of simple to understand.
Yeah.
Truthfully, like, and this goes through. So I can't really. I'm trying to remember. This goes through, and none of those two are like that great, right? Like none of those two, if you were to iterate through the first two, are that great. K-means isn't even perfect either, but it's far more optimal.
They're all suboptimal.
Yeah, they're all
Yeah, that's an important point too.
Yeah.
exactly. And then I think what we found from K-means.
So can we go over those definitions real quick though? So optimal. So if I remember, like optimal, like minimize it. Yeah. Wait. What's the definition of optimal and suboptimal?
Optimal is the absolute minimum. Like you ran the calculation, and the calculation took forever, and it did a perfect nearest neighbor comparison. So you have the absolute minimum of that number.
I feel like wasn't it mean like when J clust is 0 or something like that?
Well, that's what I was about. So it minimum. Yeah. What does it find the minimum of to be optimal? It minimizes J clust.
J clust to the true minimum.
Okay.
So what's going to happen is we're going to converge under K-means to the minimum, and then it's going to stop adding value. Like we're going to say, we don't need a more accurate number than this anymore. So it converges towards that number, but it'll never attain it because you're not running it infinitely.
So, and just to be clear, so when J clust equals 0, that's when there's each vector is a different group. There's one vector in every group. And it's
but that is varying K. See, like K is the number of
groups
representatives that we have. So like if it was 0, then K would be high. It would equal the number of points.
K equals the number of vectors or points.
Yeah. And the selection of K, like how many K do we need, really comes from that point where it says, like, you look at a graph of J clust and you say it's not really improving anymore.
So you
that's how you know what K is. So K is your input. So K nearest neighbor is an input. It's a parameter.
So you're right. Like the optimization of J, it's just minimizing J cluster. Like J cluster, like you pointed out, Shane. The only way really you're getting J cluster to 0 is if they're all individual clusters. But the optimization, like Michael said, is really just the absolute theoretical minimum from a data set
that you could get.
Given K.
But that's obviously.
But none of these algorithms that we're looking at right now will do it for the exact reason he said is you'd effectively have to run it forever.
It's computationally too expensive.
So
you have an optimal.
Impossible, really. Like.
Well, it's just very slow. You can do it with smaller data sets. Like the examples from the textbook that they show in those graphs, you could definitely do it with.
Right? Yeah, and I guess you could check.
But
check every single.
The reason why people use K-means is because it's a very robust algorithm.
Well,
meaning, like, you can run it on millions of data points and it really won't take that long.
Right, and when you look at the graph, it doesn't require all. I mean, besides the complexity here, which is really what the issue is, but it doesn't require much more than 10 or 11 or 12 or something iterations.
Yeah. That was.
Like
a good point too.
Real quick.
I don't know where it is.
A little bit.
It's in the textbook.
Oh, right here. This is what you're talking about.
Graph, right?
Yeah.
So iteration around 9.
See J cluster exactly.
Or 10, 11. So 11, it doesn't improve anymore. So
just sort of asymptotic.
It just stops.
11, 11, and certainly 12. You would, right?
Okay. If you guys are good, I'm good.
Yeah, let's.
We can fit.
Let's get into
the last
it.
thing about this book section, I think, was the handwriting. I could be wrong.
They did a classification with the handwriting and then the classification
and the histograms that match in the topic modeling.
Shane, we even did that. I even did that in Wolfram, like where we pulled in the Wikipedia.
Yeah.
So this took Wikipedia articles and just did word histograms and used the same. It used K-means, right? It used
it's topic modeling, they do that with like movies.
I think. What did it use? Didn't it use? I think it used K-means.
Well, normally what you do is you can say I have a bunch of descriptions, right? I can convert them all to vectors. I can parse them and then convert them to like frequency counts. And then once I have the frequency counts on the document to word matrix, I can run K-means on it.
Right. Right.
it'll reduce those to topics.
I think
The
that's,
documents
Yeah,
to
I think that's
topics.
exactly.
Yeah, that's
what it is.
exactly. Yeah, that's
Yeah.
exactly what happened.
So
They did.
so
Okay.
just to summarize to reiterate exactly what you just said, is it pulled random Wikipedia articles, deleted the stop words out of it, which is the in
Yeah.
Yeah.
and it did frequency counts of them, and then it basically analyzed the vector space. It basically looked at
Yeah.
how far those frequency vectors were from other ones,
Yeah.
and basically
Yeah.
created a feature space of like this topic and this topic and this topic,
Yeah.
Yeah.
whatever. Yeah.
And the thing is, once you have those topics, they're cluster assignments, right?
yeah.
So you basically have an additional categorical variable that you can use in a regression as well. So say you had a numerical value, you could use that categorical to regress it to be
What do you mean? What do you mean? Like so
say I was trying to maximize the movie rating,
Yeah.
right? And I could have a categorical input variable of topic
Oh,
because I went
see
through all
what
the
you're saying.
text.
I see what you're
So
saying.
you can then use those as inputs,
You're
and
saying
you don't
this
have
is
to
the
have
first step.
every single word.
Yeah.
The alternative is like
Oh,
way too
wait,
heavy.
just so I might be confused, but are you're saying that you can feed the topics as inputs into some other model instead of feeding
Yes,
the words themselves?
that's normally how it's used.
Yeah.
Yeah.
Because
Okay,
that
cool.
would be more
So like the
complex
famous
and
case
smarter
study with
than
this
you.
is like movie descriptions.
Hmm.
And there's another one where there's another kind of interesting one where they did authors. They were trying to identify anonymous authors of like certain papers, and they were able to identify them through using this clustering algorithm.
Nice.
Cool. That sounds sick.
Yeah, so you can do some pretty cool stuff with that. But
You,
let's just get into the basic.
You want to get into
Yeah,
the
it's,
Julia side of it, Mike?
Yeah, sure.
So I'll share the Julia notebook on my. Oh, here we go. We got it.
I got it on here.
All
So
right.
basically what they did was they just created a this is their
A
JClust.
JClust function.
Yeah. So apparently I can't copy.
So is this JClust function?
Wait, can you read? Can you read
The whole thing? Yeah. So in Julia, we can store a list of vectors in a Julia list or tuple of n vectors. If we call this list X, we can access the ith entry using xi. To specify the clusters or group membership, we can use a list assignment called assignment, with assignment I is the number of the group that the vector xi is assigned to. In VMLS, we describe the assignments using a vector C or the subsets group J. We can store the K cluster representatives as a Julia list called reps with rep J, the jth cluster representative.
Okay. So they're writing a JClust function that takes in looks like an X vector. Is X a vector? I don't know.
Yeah, an X vector of size n.
A vector of the representatives, because you basically
Of all the
find
representatives.
to every representative. Right?
You have to,
find
for
one
each
cluster.
one. Yeah.
Yeah. Those are your Z's, right? Those are your Z's.
Yeah.
What is the assignment? Assignment is the number of the group.
Yeah, what is assignment?
So
The number of the group that vector xi is assigned to.
I guess we're gonna be
Yeah.
building out k-means because it's already assigned then, huh? So
Yeah, we're gonna. It actually they give you a function for k-means in here, which I thought was cool because you don't see that in any other textbook. They don't give you the actual code for it.
Right.
Mm.
Okay,
So this is
yeah, go ahead.
assignment I is the group number that is going to be, so it's going to give us a group number and then we'll grab that particular representative for that group.
Right. So
Right,
if
that's
if,
how it
if-
works.
If some right. So let's say x3 was so assignment will just be like let's say this is, I don't even know how many groups there are, but let's just say that there are like 3 groups. So assignment 3, x3 is assigned to group 2 or whatever. So reps 2 is just giving us the leader of that
Yes.
representative.
Yeah.
Yeah.
Exactly.
Of that
Yeah.
cluster. And then it's saying what's the distance between that particular wait a minute. So
The
X,
distance between
so
that
is
vector
X a
and its
list of
representative.
vectors?
Yeah, it looks
Yeah,
like
X
it.
is a list of vectors. Okay, okay, okay.
It's a list of
It's
vectors.
it's an okay, okay. Yeah, maybe that makes more sense anyway.
Yeah, it
Okay.
does.
Yeah.
Because X has multiple dimensions.
No, I
It's
totally get that. I just thought we
yeah.
were putting one vector in. I was like really confused. I was
Well,
just
not even that it has multiple.
No.
The individual vector could have multiple dimensions, but it is literally just a list of each of the vectors,
a
right?
bunch of vectors. Yeah. I mean, and so just to be clear, just to be totally clear, so X is a multi-dimensional array, right? Assignments, however, right? Assignments is not. Assignments is probably a flat list, and
Assignment
reps
right
is
here.
right,
1,
exactly.
2, 1.
And reps is also a reps is
Yeah.
also
Yeah,
a
like
multi-dimensional array.
imagine X as like rows.
Yeah.
It's a bunch of rows, and it might add a column called assignment.
Yeah. I mean, assignment is literally just the list of possible, Yeah, exactly.
Like these could be
Yes.
lettered. They don't have to be numbered. They could be like A, B,
This
C,
is
D.
so assignment is C in the text or whatever.
Yeah.
So here it's saying 1.
Yes.
It's saying that this vector belongs to group 1. This vector belongs to group 2. This vector belongs to group 1.
Right.
Is it
Right.
right?
Right. And then since there's only 2 groups, that's why reps is only
it's the length 2.
Yeah, exactly. Is it 2 by
But yeah, but obviously, and this may go without saying, but obviously each element, each rep is going to be the same number of dimensions as
It
each
has
X
to be,
vector.
Yeah, they have
Yeah.
to be the same. Otherwise, you're talking about 2 different types of space.
Yep.
Let me see. I wish you could just copy this function.
All right, so let's let's go through it and
you gotta.
I'm
get
typing it
the
in.
muscle memory.
Wait until we get to K meets, then you're gonna be like, no.
I know.
Let's see.
Right.
Okay, so we got J cluster. I think I got an error in here in one of my brackets. Generic. No, this works. This is
alright.
perfect.
It looks good.
So assignment is C, reps is Z, X is a row of data.
So I forgot that they had a norm function straight out of the box, huh?
Mm.
You didn't
out
have
of
that, right?
VMLS, right?
Oh, yeah.
I think it's with
Did you pull
VMLS.
in VMLS, by the way?
Yeah,
Oh,
let
you
me
have to do that, yeah.
What is it? It's
Uh,
using,
so
right? I think it's
using
isn't it using?
It's using.
Oh, maybe use.
What are the other ones that we normally use? The other packages?
Sparse arrays and linear algebra. Yeah, I think that's right. Yeah,
Is it capitals?
I think that's right. I think you got it. I believe.
Okay,
Let
perfect.
me check on my thing too.
We'll just run it, see if it runs.
Yeah. So let's see. We got.
Yeah. What was it? Package status? What was the thing that? Oh wait, that's what it was.
Oh.
What happened?
No. It was
Yeah, it's package
no,
status.
no.
Okay, yeah. And we might need plots, just a heads up. And that one takes a little bit to compile, so if you want to start running that. Whatever, dude. Thanks.
Lowercase or uppercase?
Where are you? Sorry.
What?
Oh no, you're good. That's it. You're right.
Oh, I thought you were talking to me.
So,
So it's plots with an uppercase or lowercase?
plots is uppercase, yeah.
You can't do the closed square bracket to get into like the import packages
Not for,
in
if you're in
Jupyter or anything.
That's what you're trying to do.
That's yeah. It's
No, if you're doing that in Jupyter, you're gonna use the package. So you're gonna use PKG, and then you can sort of use PKG. You might be able to do the bracket thing, because it really is just sending it down to the REPL, but to the runtime. But I just don't know. I know you can do the help menu, on in Jupyter, but it's not really the same, right? So I think you just kind of try to avoid it. So those are really just macros anyway, because you can use the package stuff, and then you can use the there's a function I believe called help. It's itself. Yeah, there's a function called help. So I think you can just type in help and then whatever you're trying to get help with. I believe. No, maybe not.
Okay, yeah. So you see how they defined it. So if X 3 element rows,
Yep.
Mhm.
Yep.
reps
sense.
2, and then assignment you get 1, 2,
Okay.
3 for each element.
So now we just pass those to JClust.
Yeah, I'll just go JClust,
Tiny little data set.
X comma reps. Comma
I wonder if this book is gonna get in. Like one of the really crazy things that Julia can do really well. I just spelled it wrong. Is like distributed processing and like shared arrays and sort of these like event driven channels and really cool, like really fast, powerful stuff. I wonder if we're gonna get into that. I don't know if that's beyond the scope of the book, but
Wait, hold on. I mean, maybe I'm missing. I'm missing something here. But when they redefine assignment, they end up getting 1.333.
yeah, that's
Yeah, it doesn't really make
doesn't
much
make any
sense. No, they are okay. So
That makes no sense.
when by assigning them to different clusters, they're increasing the distance
Okay.
Yeah, but
because it needs to measure the distance to the reps.
But Shane's asking how come when the person writes assignment equals 112 that it prints out.
that's got to be a mistake. It's got to be a mistake.
That
There's
can't
no
be
way,
right,
dude.
man. That
Doesn't make any
makes no
sense.
I don't know.
Unless you have some weird like the macro or something. But we
I don't
did
know how
that.
they ended up with the decimal. That's for sure.
Yeah.
Well, let's
no,
okay. We'll do
it's a
we'll
flow.
do it, and maybe
Yeah.
somehow, and if that is the case, then we'll figure it out.
Undefined variable error.
You know what's weird about that? That's the average of that vector, right?
Yeah,
4 divided
yeah,
by 3.
yeah.
So that's
So what am I doing wrong here? I have an
sorry.
undefined variable error.
I think they forgot to put average assignment.
No, go
We'll
to
see.
your thing, Michael, go to your thing again. Sorry, I can't see the Jupyter.
I'm getting an undefined variable
No, I
error.
got you. I know. I see it. Hold on.
Let's
Don't-
see.
don't-
Assignment not
Oh,
Don't move.
I spelled it wrong up there too.
Okay. Oh yeah.
boom.
Okay.
2.
Okay, so let's see.
Can you see if you
And
get
then-
that same thing? I just don't believe it. I just don't.
No,
There's no way. There's
they're moving stuff around. You know what I mean? The second you start moving stuff around, you're gonna get a different number. I don't know what different number.
Hey,
I'm a
do you think by chance, Michael, that you can just share your Jupyter and have the other notebook on the side, and then maybe Ida?
Yeah, I can do that.
Maybe Ida, if you don't mind.
It's just not
if you
big
can
enough.
just
It's
pull up
really
the Jupyter
small.
one, so that way we just keep the
Yeah.
screens kind of.
Okay, I got it. It's brighter.
do we want to do over under bets
What's that?
on this on this assignment? I would bet a lot of money.
I don't know
Is this big
why,
enough for you?
but I don't see how it's possible. Right.
I would bet my life's earning right now
wouldn't
on
do
this.
that. I wouldn't do that.
I'm a gambling man.
Oh God.
It was like you've been working like I don't see.
You want me to share the Julia book?
Yeah, I was thinking if you could share the Julia book. And then
Wait, they didn't even rerun JClust.
See? Yeah, of course it didn't rerun it. Like it
You know,
doesn't-
you're pretty. You might be right.
If you rerun JClust now that might be 1.3. Yeah, exactly.
Yeah.
That's.
So there
There
is
we
an
go.
error. We should write that
They just
down.
they left out a line.
They just left
They
out.
left out
That's all right.
the JClust, whatever.
All right.
All right, let's see.
I would.
This is the part I don't want to have to type. Assignment representative.
I would have made a little bit of money on my life's earning bet right there. You know, maybe not a lot, but
Okay. So now we're gonna do K-means.
Oh, by the way, I don't know if this is appropriate comment, Shane, but I saw like your girlfriend posted this thing like, oh, 3 years ago this was our first cyber date or whatever. Did you see
I don't
that,
know.
Shane?
Nah, I didn't.
Well,
I don't know
it's
if I want to.
embarrassing.
No, it gets worse though, cause
What?
she and him had no idea that whoever, like, I don't know which one of them it was, but whoever, like, now think of it, they're saying this is our first date or whatever, and in whatever
You
service
keep it right
they
there.
went on Verizon,
The textbook.
somebody in big letters on the top just said virgin, and I thought that was like the funniest thing. So like she's like, this is our first date, and it just has like huge letters on the network thing. It says virgin.
Oh, because of the phone.
Yeah.
Oh,
Dying.
that is funny, dude. You just made my heart race a little bit. I was like, oh no, is there something bad? Like,
I don't
That's
know.
so cute.
It doesn't
When
post
was
it.
that?
this is a long time ago.
No, I mean, when was the anniversary?
I mean, it was.
Oh, I don't know.
Anniversary. It was in.
I don't know. Yeah, I don't think
Literally
it
like
was.
anniversary of their first.
It was like a
cyber date. It was a
Facebook. Yeah,
anniversary. Yeah.
yeah.
Very cute, but yeah.
I'll show you the picture. It's so funny. I wonder if she
That is funny.
commented on it because I wrote that right on the Facebook page. I was like, oh.
That is funny. I thought there was gonna be like something bad in the video or the picture or something. You got me
No.
nervous. I was like, oh
Shane,
no.
What have you,
I was like,
John?
I
There
don't
must be
know.
some pictures of Shane
I
is
have
nervous
no idea.
about.
I don't know. I was thinking. I was like,
Picture. She did it.
I was going through all my history, in my head, everything I've ever searched on Google. I was like, what the
Oh,
heck
no.
is he about to say?
Well, getting anything like that, I'm sure it didn't.
That's funny though. All right.
I don't know how to get this Hangouts from stopping to switching screens so much. I'm trying to.
It's so small.
Yeah, and it.
I got it.
But
Why is it in? See, like, is this a Jupyter Notebook thing that it indented?
I don't know. So what is max iters? Oh, max iters.
Oh, that's how many iterations before it
Yeah,
shuts
yeah,
off automatically.
Max hitters. Yeah.
Because without this, you get stuck in an infinite loop.
Hmm.
Or with and if you don't converge to the tolerance.
If you don't,
level.
yeah, if it doesn't converge.
Ida,
And,
can you scroll down a little bit
Yeah.
to get? To
Yeah,
where-
perfect. I
to
can
what
see
I
it
was
now.
typing?
Alright, so n equals the length of x, so it's the number of entries.
Okay.
Small n equals the number of dimensions.
So okay. So this is they're writing their k-means algorithm.
Yeah.
And when do they? Max iters. I was like, when do they
Mhm.
stop? Okay, so they're gonna do it 100 times.
Mm.
So you're making a so you're starting off with a zeros vector.
Of the length
Interesting.
of all of them,
Not just
of all
like a zeros vector of distances and a
of the
zeros-
number of points.
and a zeros
Oh.
vector.
Well, I have a feeling.
Used to store the distance of
Yeah.
each point to the nearest representative. All
It's
right, so that,
probably
Yeah.
that makes
just
sense.
trying to create a
It's the same as the.
yeah.
That's why it makes sense. It's the length of x.
Yeah.
And
No,
then
but
for
I'm
reference,
talking about, I'm talking more. Yeah, okay, that's fine. I mean, I'm talking about the distances and the reps. It's creating zero vector. It's probably just wants
yeah,
to create the space or something.
for each group. Okay.
Yeah, I mean, it's creating. There's k clusters, right? That we want. It's creating a zeros vector of the right size.
Yeah,
like you pointed out before, and it's creating the distance from any.
Yeah.
Okay, it does make sense to start a zeros vector for distances because when you start, every
Yeah.
point's in its own cluster. So
Yeah.
So in effect, although
And it's just the same.
weird to call
It's the
it-
length of x, right? It's that length of an individual x. Sorry, like x1, x2, x3. That's why it's zeros n, right? Because this is the length of x. You have a zeros vector that's the length of x, and you do it for each group. And then that makes
because
sense
the
to start all the
capital
reps like
N
that.
is the amount
Yeah,
of
but there's
vectors
only
you have.
really k. There's like k rows there, right?
Well, okay, so the row, so capital N is the amount of vectors that you have, and
Yep.
little n is the size of each vector,
Yes.
because you're just pulling off one vector and seeing how big it is. And
I think
So yeah, it's the number of dimensions that it has, like across
it's the number of dimensions is little n by capital N, or however you want to write it.
yeah.
Yeah.
So this is
So then, okay, so then it creates, so what's it doing for the assignments here? It grabs a random.
It's randomly. Okay, so no, it's not. Wait, it's randomly. Yeah,
From one to the
it's
length
just randomly
number of
assigning.
groups.
It's randomly assigning. So it's taking a random.
Oh, yeah.
from
4i and 1
from
to
all the
n.
clusters,
Yeah.
and
Yeah.
doing it for each vector, and it's just
Yeah.
randomly assigning them.
So you're going to end up having a list
We talked
of
about this though, actually.
yeah.
in the
It's
book,
just
when they do total random assignment, no matter what you do, around 10, 11, 12, whatever iterations, you're going to end up sort of being close to the right place in the end anyway. This one's going to do 100
number of
iterations.
iterations now. What are you're talking about the max iters, or what are you talking about now?
well, this is the initialization, right?
Yeah, if you initialize it the worst possible way, right? It still is. I don't know why they have 100 iterations. That's interesting. It's still going to, after whatever it is, 12, 15, or something like that. What is the TOL thing? The tolerance. What does that mean?
Tolerance. Where is that?
That's an argument.
Oh, up here.
Yeah. It's got some tolerance. It must have to do with the Julia itself, and like the size of digits or or whatever.
Yeah.
Or it could be shorthand. I could probably.
I mean,
What is 1e to the fifth? I gotta shift it 5 decimal places.
Yeah.
No. Of course it's
Well, it's just-
shorthand, but why do they even have it? Is what I'm saying. Like, why is it even?
Yeah. What's the point of it? But it's definitely just doing arithmetic. It only goes,
It must be
to
on
a
the
certain,
next
like
page.
to the 5th decimal or whatever.
Yeah,
Or something.
it's like this. It's that number.
Yeah,
No,
but
no,
like,
I
what's
know,
the
but
point of it?
What's the point of it? Like, I don't see. Hey, Ida, can you scroll down a little bit, maybe? Is there another gray box? Oh, there is. Okay, so where's tolerance? Oh, right down there. 50
Keeps going.
So it's say
34.
Yeah. If the absolute value J and J previous is less
Wow.
than tolerance times what's J? J is the
That's J clus, right? Yeah, it is.
It's the average distance. Average norm distance.
The distance is square.
Yeah.
Oh,
yeah.
that.
So it's like, Okay, well, I'm looking forward to talking about that.
Yeah, well, that's how I was taught K-mean. So it's Euclidean distance squared, and then some other algorithm will use like absolute value, and some other algorithm will use like different measures of distance. They use different measures of distance. All the ones that are K-means like.
Yeah.
And then there's like a whole nother school of these clustering algorithms that use eigenvectors.
I mean, the concept of distance, right, doesn't have to be Euclidean.
It doesn't change very much, yeah.
It can be.
So there's not much. That's like one group of clustering algorithms.
Right. If you can.
The other group has eigenvectors.
If you can. Right. There's a million ways you could do anything, right? Because like this could be, if these points in space are just like, like distance is like, if you thought of like how do I want to get from A to B, and you say, well, distance is the hardest. Is really what but except what if there's a mountain in between me and B, A and B, or there's a moat with alligators or whatever. Like
that's called a.
Well, you're just all it is.
There's a word for that.
Yeah,
I
but
forget what it's
all
called.
it is it's a graph, and you're waiting.
Oh, it's called a localized minimum, or localized maximum.
Yeah. I mean, and all you're doing is waiting what distance or difference means. You're just saying like, it's the same thing as you said. There are different ways of calculating quote unquote distance, And in a graph, it's edge weights, right? The same thing that Google Maps uses to find out what's the fastest way for me to get you from A to B. It's not necessarily the distance from A to B. It's the roads you drive on and all sorts of varied traffic and all sorts of other things. So you have edge weights.
So I think, sorry to digress, but to go kind of back to the tolerance thing, it seems like we can set the tolerance to whatever we want, and it's kind of like our threshold of saying this is when we're going to stop.
Right.
Okay,
so max iters means it's going to stop there no matter what, right? So
once the improvements start getting once the improvement starts to get too small.
Yeah.
That's actually what it is. It's once the improvement from one J to the next starts getting too small, then we're just like, screw it. We're not improving anymore. We're done.
Yeah.
But the thing is, you may never hit this tolerance level.
Yeah.
But you'll hit the max iters guaranteed.
But you'll
definitely hit the max iters.
And you can also hit a localized minimum.
Yep.
Like if the graph goes like that and it curves up and then it comes back down and goes even lower, then that's a localized minimum.
But if the local minimum is below the tolerance times J, it would just stop there.
Yeah, it'll stop, which is why there's variations on this algorithm that play with the initialization. The initialization is really important.
Okay, I see. So if you have some sort of function where it's not just, improving the whole time.
Yeah, you might want to test if it's a localized minimum somehow.
Yeah, like slope.
But that exact same problem exists with gradient descent. So basically, in all of machine learning, you have that localized minimum problem. Okay, so let me finish this function. So I got assignment. We call it JPrevious. Here's INF.
What is INF? Infinity?
Yeah.
Sorry, it's infinity. Yeah.
You keep the textbook up.
Oh yes.
You're like my eyes.
I'm scrolling all over the place. I know. I was just.
Yeah.
Shane, you can you can scroll. I'll keep the textbook up for him. What page
Okay.
What page is that?
Right now I'm on 34.
Oh, you're on
The Julio.
Too? Okay, so never mind. I'll keep it because Ida has that too. So yeah, so Mike, Ida has it as well, so you can click on her thing.
Okay, let me.
I have the textbook itself up. So.
Okay, perfect.
Yeah, we're on the same one.
See if I can make my. So this is like the main part of the.
Okay, so it iterates through each group, and then
there should be 3 loops in here if
the assignment equals if that vector is part of the group that you're currently on, then iterate. Yeah, wait, what? Is it? What is it trying to do?
There should be 3 loops.
Oh, it's just trying to grab all the vectors in that group. Is that what is going on here? Or
What part are you looking at for J equals 1 through
17 to 9? I'm looking at 18 specifically. What exactly does this group list represent?
Okay, so that for loop is definitely going through the clusters.
Yes.
All right. So and then it's saying capital N is all the vectors, right? So
yeah.
So for all the vectors, for each vector we have, if the assignment is J, so if the assignment
go through, so Yeah, if assignment I, which is going to tell you if that vector belongs to this J
Well,
group.
so 18 is literally getting a group. So it's finding all the things
Yeah.
that belong to a certain group.
Yeah, yeah, yeah.
And then
Yeah.
it's assigning the okay, so then
It's grabbing all the indices that belong to a group, creating a list of all the indices that belong to a group. I.
Yes. Yes. It's creating all the indices that belong to a group. Yes. So group is just going to be a list of like 1 over k ish of the population, right?
Mm-hmm.
Ish.
Yeah.
And then for each group reps J is the representative of that group.
That group,
Yeah,
that
yeah.
Jth group,
And
and that's going to equal it's going to the average
the
of all
average of
the
group.
vectors. Of the average of the group, yes.
Wait a minute.
Where's my n?
What is this?
My n should be right.
Why?
You take this. What's Yeah, wait, what's wrong with that?
Because it's the because
fine.
this is back to what I was talking about before, where it's a theoretical point. It's
Centroid.
Yeah,
it's
it's
not-
a
yeah. I'm like, wait a minute.
Yeah, they're taking a shortcut. I was wondering why this was so short.
I'm like,
it's
how is
literally-
doing
yeah,
math? Yeah. It's just finding the centroid.
it's literally just the
It's
average
it's
of
the centroid.
that. Yeah,
It's
the
finding
centroid.
the
Yeah.
centroid of that group, right? And it's setting it as the representative.
Yeah. Cool. So then now next it finds find the distance to the nearest representative.
You can go to the next page now.
So it's probably
Okay.
it's gonna iterate through.
Okay.
So for each of the groups, it grabs that representative and finds the distance between a vector and each of the group, but then finds the minimum distance between the vector and each of the group's representatives.
So wait 1 second. So it's finding the norm. Right. So it's finding the distance of each vector to its group representative.
But it does it for all the
Each
groups.
Group representatives.
Yeah, for all the groups.
Yeah.
And then just grab the minimum of that,
And it's setting.
the minimum distance.
But why is it setting?
It sets it to two things here.
Yeah, I'm a little confused.
A tuple somehow. So find min somehow returns.
Yeah, let's explore that because I don't know.
What does find min return?
I don't know. I'm checking it out. I don't know. That's.
Oh, my mistake. Oh, no, that's not a mistake.
No, find min does return 2.
Yeah, what is it? It's probably
It
returning
returns
the value
minimum value and the index.
and the index. Yeah.
Yeah. So okay, that makes sense because then it's the assignment is literally the index.
The
right?
distance is the value, and the assignment is the index that it
Yeah.
returns. Okay. And it
Yeah,
does it
because-
for the
because-
ith
because
value.
The
Yeah.
index is just gonna be like J, right? It's gonna be.
Yeah. Well, the index is I. The index is I. J is like the group, the representatives. It's the group's index.
Sorry.
But I's the index of like the x vectors.
Sorry. The assignment vector only has J's in it. Is kind of what I guess I was trying to.
Oh yeah. The assignment vector is going to be
A
1 to
vector of
k.
J's, yeah.
Yeah.
Okay, so that's interesting. So the norm, it finds the distance of that particular vector, I guess you could say.
To all of the leaders. To all of the
each-
representatives.
Right, each leader, because it basically what we're looking at is a nested for loop. So it's
Yeah.
running through
Yeah.
it's running through for each I, it's running through each J.
Yeah. Yep.
Yes, this is basically what I was trying to explain with the dissimilarities. So you end up with like 3. You should end up with 3 for loops if we're right.
Where's the What do you mean the third?
There's one on the outside, and there should be. I mean,
Oh,
like,
'cause you're saying because of the iters, the outermost is iterating through the.
yeah.
Yeah. Because
I think they eliminated one of the 4 loops, so this is like a shorter way of doing it.
Yeah, I mean this is.
But in the pseudocode version of k-means, there's like three, 4 loops.
right. So
I mean this is.
I mean, this makes sense. You have to.
Yeah.
You have to. So I mean, the k-means is 3 is besides like so it's got the number of iterations like we said until we decide we're done or some way somehow. But it's got the group assignments, right? So it's that's where you find the distance to each centroid. Sorry, it finds the centroids, and then it finds then it reassigns things, and then it iterates again, and or based on the condition.
Yeah.
I mean, that's all it's doing over and over and over again.
Yeah.
Yeah, it's just calculating the.
Yeah, it's actually a pretty intuitive.
It's intuitive.
Algorithm.
You're never gonna see it this simple. This is like the shortest one I've seen so far.
Mm.
I saw one in VBA. It was like.
Yeah, it's. I mean, logically, I think it's intuitive. But it's also probably pretty easy to make a mistake.
Yeah.
That's kind of.
Especially the other way. If you do it the other way, it's a lot more confusing. Let's see.
All right. So what do you? So you're doing. You're iterating for each. So you're on that line right now, where it's the distance and the assignment for each eye.
Tolerance stuff.
J.
And then you compute J.
There's a capital J.
Then you literally just find what J is based on all the distances.
So
and then this is the last step we talked about before, where we're deciding if we stop or not based on the tolerance and the improvement. And then as with any loop like this, you got to set the previous one to what the current one was right here. Okay, cool.
Line. So I almost got the whole thing down.
So J is over N.
Yes. Yep. The distance is squared. The norm of the distance is squared over N. And there's nothing tricky there. I don't think that's how it was. That's what the formula in the text was as well.
So just for stupidity's sake, because I always like to remind myself, the norm the squared sum of squares. No, sorry, the square root of the sum.
The square root of the sum of squares.
Yeah. So then you're squaring it, so you're just getting the sum of squares over n for J.
Yeah.
So what this is Julia question here, but what does and do?
And
it's just a logical and.
I think it's just and, yeah.
It's the same.
Just like in
ampersand.
It's and in Python, I'd imagine.
That's so funny because you must be a Python guy because like any C language uses that double ampersand.
Yeah.
So like most languages use the double ampersand or the double ball.
Well, and can also indicate when you're concatenating. Like if you in some languages.
In like VBA.
VBA, VBScript, VBNet, VB, like all the VBs is always a concatenation.
Yeah.
So
no, but
one thing.
Funny. No, I'm just commenting because it's very interesting because, like most of the C-based languages, like
So this is literally like
and or the or is the.
This is like and.
Lines.
If I wrote and,
yeah, it's the same as and. Yeah.
Most of the C-based languages use the double ampersand, but Python, which I think you can do that. I'm pretty sure in Python, but they also differentiate between the word and that, and they're not. They actually have subtle differences in a lot of languages. I don't know why Julia didn't do that, but
I think so one other point is the norm here, which it was good that you brought it up. You're also keeping, so you're finding the norm of the distances squared, so that takes out the square root, but the distances themselves are obviously also the norm between the vector.
yeah.
Why does it
And-
keep doing this
That's why-
indentation?
That's why I was
so
kinda like,
so
whoa.
it's an important thing to point out. Here norm literally means distance. Here you're just you're squaring it and taking away the square root and just summing up all of them
Right.
squared.
Michael, where you define J, I think you have to divide it by
Yeah,
N.
yeah.
Yeah, I
because-
gotta divide by
Yeah,
N.
you want it to represent the
Capital N or lowercase n?
the
Capital.
Capital.
Yeah, because you want it to represent the entire vector space.
Yeah. Okay. Now I'm gonna go end. Why does it keep doing this
I know,
indentation?
that's weird, man. I don't know. That is kind of strange. That's really annoying. Oh,
Oh, I know.
I have no idea.
I have a feeling this is not gonna run because my indentation is probably fucked up somewhere.
Yeah, but that's the one. That's a good thing about Julia, though. It doesn't care. It just
Okay,
uses
let's see.
blocks. I don't know if that's a good thing. That's probably why it's messed up. That's why it's messed up. Because it thinks you're writing Python. Like, you know what I mean? Like, so it's trying to...
Yeah,
it's trying to end
it's not
you
built
off.
for these types of notebooks.
Yeah, that's interesting. We probably
Let's
have
try to find this
figure out the
error.
Formatting. There's probably a correct formatting thing we can
I
figure
got space before. Not. It doesn't say what line it's
Yeah,
on.
no, just so let's, yeah, where do you have a parenthesis?
1 to 2. I don't have that anymore.
Oh, so
Can you
you
go up?
probably just have a function and then you have a space and then you have a parenthesis, whereas it literally needs to be right next to the parenthesis.
Oh, okay. Oh, it worked.
Nice.
Well, let's try it on something. Can you go up before the k-means function? Just before it has.
It's
Where?
Okay.
assignment representing k means xk.
This one?
Yeah. That I don't have in there. What is this for? Why are they doing that? I didn't write it because I know why they were doing it.
I think they're telling us.
They're unpacking something.
Well, are you
Like-
what are you returning from k-means? Probably two things, right?
Yeah, let's see.
Is this already a function that we just defined?
Yeah, you return two things from k-means. I think it's just telling you that this is what you give k-means and this is what you get out of it. I don't think it's telling you to run that.
And okay, so these are. I just want to go through like a few things in here. So this max iterations and tolerance, this semicolon indicates
It's probably the difference between
optional. These
yeah,
are optional parameters.
or parameters that are set by default versus not.
Yeah.
Yeah.
Okay.
That's actually.
So that's just a technical Julia.
Yeah, that is
I didn't
interesting.
realize that. So
That is
that's kind of neat.
for
I mean,
sure
like,
interesting.
Python just eliminates that.
Yeah, it looks like
That whole concept, but I like that.
Well, it doesn't eliminate it completely. They still
No,
make
I mean,
you the
can
order.
do-
Like
you
I,
can do that, but the problem in Python is like you can't, like if you have default and if you think this through, this is why it can't happen. But if you have default parameters, you can't put a different parameter after your default ones. So like you can't.
So I'm gonna move this down here then because we're just unpacking.
So he
the-
couldn't. So he couldn't, for example, put like a different variable at the end of all those. Does that make sense? So, like,
yeah, he
Python,
couldn't have
you
a
can't say
new
function
variable at the end.
f of a equals 1 comma b won't work, and it won't work in JavaScript either. And for good reason, because like the idea is that you can pass less variables in, and it doesn't make any sense.
Okay, that worked.
If you're putting them after the default ones.
Yeah. Uh,
I think that worked. I don't know what this is.
all right. So
That should be your assignments and your.
okay. So
So
should we,
I just input. I made K2.
yeah. So you have only have
But
two.
it's
oh,
just,
so you,
uh,
you put in some variables and you got some output
So yeah. So you
from
only
your
have,
function.
So now
So
you should have. What the hell?
Well, this doesn't look right at all.
Wait, what's going on?
let's
What
see.
is X?
Yeah. What is that?
X is a list of all the vectors. Excuse me.
Yeah, which they previously gave us. So we have 3 data points.
Okay.
Yeah.
And then reps is. Well, I should keep it at 2 then.
Yeah, put it 2. That's what the example was. Oh, and you get okay. So you get this output.
No, but see, this has 3 in the.
No. But how long? How long?
So what are we? So we're outputting here the
Oh, these are the
assignment
assignments, and these are.
yeah. So X has 3. So it makes
Okay,
sense
so
that you're
then,
getting 3. There's 3 X's in that list. So you get the assignments to the groups. The first X goes to group 2 in this example. Second group's 2, and then third one 1. And then we also outputted the reps, which are there's 2 of them because there's 2 groups,
Michael,
and
wanna
they're
see something
of
cool?
length 2 because
So,
X is of length 2.
Michael, hold on.
So
Hold on.
all of that makes
Hold on,
sense,
Shane,
I
can you hold
think.
on a second? Mike, can you erase that? I want to show you something. Just if you can erase all the way.
So because there's only one value, there's only one X value in group 1. The representative should literally be that X value, right? The third X should be the same as one of those representatives.
Wait, say that again.
So the third X is there's only one X in group 1, right?
Yeah, but
It looked like-
representatives don't have anything to do with, as far as I understand, the representatives don't have anything to do.
Oh,
with,
it's just an average. So it should just be the average of that, right? Or the
after running the algorithm, but yeah. I mean, you're kind of
Okay. Do you guys want to do more k-means? I have like lots of notes on k-means.
It'd be nice to see
If you want me
sort
to,
of a bigger data set.
What
but-
I guess what I was saying is we could easily calculate to verify that like the representative is correct in the group that has one X value. I guess we don't have to.
So
yeah.
the group that has one. Wait a minute.
And well, when I input 3, if I input 3,
Oh,
It lit-
I see what you're saying.
You,
Shane.
you
Yeah,
saying,
everyone-
John?
But Shane's saying like so there's only 2 groups. So obviously two of them went to one group and one went to the other. The representative of the one that's by itself needs to be itself. If it's not, that's a little weird.
yeah.
So what you're saying, Shane, is so the second X
Well,
should be the
second X in this case.
should be 1-1.
technically, it shouldn't matter if the
If it's by itself or not, because it's just to get the representative.
it has to fall in somewhere.
Yeah.
And
it's-
like you got 3 dots over here,
yeah, I
3
agree.
dots
It's still
in
calculating
one
stuff.
cluster,
It's not.
and then 1 dot in another cluster. And that's a typical problem.
What were the
It's
X's
still
again?
calculating a theoretical average.
Yeah,
So.
it is. What were
Well,
the-
yeah. Can we just see the X's though? Because we can calculate it ourselves probably.
No, I mean, yeah. Just what are the? Yeah, if you could just. Yeah, okay, perfect.
So the
It's the
second X
The
1
second X
0.
is the 1, and its group leader is 1-1. So yeah, it's just because it's been calculating and running iterations on it.
Yeah.
Okay, yeah. It's easier to see with larger data sets,
Yeah,
but
exactly. That's what I was
you
saying.
do end up,
This is
like-
terrible.
you do end up with this problem where it's not really a problem, but like when you have one outlier will suck up your
Why
Ks.
don't you?
So like say you have like
Mm.
10 numbers and they're all in one group, and then you have an outlier of like 1,
yeah, but why don't
and you
just
do
why don't you
K
just make a
equals
data set?
3 or something like that. It'll suck up one of your
Why don't you
Ks.
just?
It'll
why don't you
waste a
just
whole K on that one point.
Why don't you?
Yeah,
just,
I can make.
just do like whatever you want with like rand 10, 2 or 100, 2 or 1,000, 2. something like that, or not even like maybe, let's see, how do you make them?
Oh,
Let's see, file?
ac-
I gotta write a for
add.
loop up here. I gotta write like a
No. You don't need a loop. Hold on.
for loop.
You don't need that. Hold on. It's just rand, and all you want to do is make sure it's a random integer. So you could do, okay. So just do, all you have to do is rand int, and then you know, yeah. So just do. We should put a max on it, shouldn't we? I was gonna say rand. If you just do, yeah.
Well, you see how they're stored in elements in here. So that I gotta write a for loop to create the elements and then append the elements.
No. Like if you do, okay. All right. I'll show you what I mean. So if yeah, you can put them in their own lists as well, because they're stacked. Is that what you mean?
Yeah, is there a
create-
fast way to do that?
Yeah, what I'm saying is you can create any.
I would like to create one like those graphs down there that have like those lots of points.
Yeah. So go to. Can you go to my screen for a second? So.
Yeah, I'm
I
trying
get
to
what
find
you're
your
saying.
screen.
I
I'm
get what
looking
you're
at the
saying.
textbook.
What? I get what you're saying about the for loop. So like if we just take a random 10 by 2 like that. Okay. The problem with that.
Okay,
is,
if I do.
What?
Are those in elements? Or are they just okay? Let me try it.
Yeah. So
Do 100. Yeah, let's try it again. Then. That might work.
yeah. So if you see my screen, yeah, it's something like that. Except you want each one. It's set like you said. I said for some reason to be in its S. So you can do basically the same thing almost. If you look at my screen, you can kind of see what I'm talking about.
Oh, ran for.
Yeah.
I
like if you're trying to
wanted-
get that, like if you don't like the one you have right there. Right. I mean,
I gotta
there's
do a
probably a
comprehension.
better way to do it, but that's basically one way to do it. Let me just see. There's got to be a way to like max it, like give it a range, you know, like.
Well, the thing is, I also want to plot this once we have it. Okay, so that gave me what I need.
Oh, okay.
So now let's try this.
If you want to
So
plot,
I'm doing 5 of them.
you can just do scatter and then I think X, right? And then you can plot it. Or whatever you just like the function is literally scatter.
Yeah, hold on a second.
It's this one.
I want to make them different colors. Because that's the only way to view it on the scatter plot.
But okay. But like I think if you like it's like ggplot, like it works in layers. So I think you can just scatter it and then you can change, any aesthetics afterwards, maybe. I'm not really sure, but it does look like they do that down here.
I forgot how we did this. What do I have to write scat? How do I write the function?
I have it on the screen.
Okay.
It's this line. I think Shane, you're referring to this line.
Yeah.
Oh,
Exactly.
I'm on the wrong screen.
This one.
Plot. Yeah. You're right. Okay, just keep it there.
So I mean, they probably won't be. They probably won't be in groups too much. I mean, maybe they will. There's a chance. But it doesn't matter anyway. We can still run our k-means
I'm
on
going
it.
to define size or
So I guess
I write scatter. Okay.
So I guess in a situation where we have a scatter plot that there aren't any obvious clusters, our k-means algorithm isn't going to converge, right? And it's probably going to go to the max iter's. That's what I would, I guess. That's what I'd guess, I guess.
I wonder how to make the colors.
Well, yeah, what happens if you literally just run scatter x though?
Scatter.
Can we-
It should
can we just
go
see?
through.
Scatter not defined.
Do you have to?
VMLS? Yeah, what's up with that?
They don't.
Scatter's not defined. Let's see. I'll Google it.
Is it called plots or plot?
Wait.
Yeah, let me see.
I don't know.
Plot not defined with Julia.
Wait, what did you try? I'm sorry, I can't see anything. Michael's.
We just tried to run. We just tried to run scatter.
We're trying to just make a
Scatter
scatter
not
plot like this.
And they just run scatter in the text.
And you
Um,
ran using plots already, right?
Yeah. It didn't let me just scatter X. Because it has them as elements. I don't know if it has them as.
No, but it just says scatter.
No, it's not. It's not letting you scatter X because it doesn't recognize scatter. The library's not in there.
Oh, okay.
I'm trying to run it.
Yeah, it
I
says
just-
scatter not
Plots takes a
defined.
while to compile, unfortunately, so I didn't compile it yet, so I'm doing mine. Okay. Yeah, I have. Oh no, because scatter takes a X and a Y.
Well, the thing is, this is how the data structure is. That's why I was saying I think it's structure, but he's right. It says scatter is not defined.
Yeah, I feel like your
Scatter,
plots
not
Yeah, I
defined.
think your plots isn't in there for whatever reason. Because I got mine.
It's called plot or plots.
Oh,
see,
S.
up
There's
here.
an S at the end.
Yeah, I had the S.
Mm.
Capital or lowercase?
That's right.
It's case sensitive.
You're right.
Okay. But we're gonna have the additional problem of the data structure, maybe.
Yeah.
But
Right.
Should
I don't. Yeah. Okay. So, what module is scatter from?
oh,
So, just a heads up that in like 10 minutes, I'm gonna try and go for a run before it gets too dark out here.
Okay.
yeah, I got some tequila that just arrived, so I gotta. it actually came. They were delivering it.
That's awesome.
Let's see.
There's got to be a way to see like what module it's from.
Yeah, I mean, even when I Google it, people have other modules that we're not using. So I don't know exactly. So plots.
Well, I
So
have
they just go
but I
plot
have
X,
plots and
comma,
scatter,
Y.
That's the thing. Scatter is in the plots package. So if you don't.
Yeah, so you're just using plots, but you did do that.
I could just do it if I change the data structure of X. I can.
Well,
How do you do help?
Can you just try to like put an X and a Y, like make your own X and Y real quick? Just do like X is one, like scatter 1 through 10.
Well, I would go plot, and then I wonder if this will work. Let's see. How do I get like the first column of? This is not a data frame.
No, it's an array, but you're looking for the first element of every. So so can
Can
you
we do
just
something like
can you
that?
no can wait, can you just transpose it and pull the first element off? So can you do x x apostrophe 1? Just print that out. I bet you that's the first element of every. Well, no. X apostrophe index that 1. Yeah, because you're the problem is you don't even have an array. You've got this list of lists.
Yeah, that was what I was trying to figure out.
Okay, so wait, what is X? X is just those list of two of 1 by 2 arrays.
Yeah.
It's just a weird because like you
This is the data structures problem. This is the reason why in Python I went through a whole thing on data structures.
I mean
Wait,
We
do
should, like for a future
yeah,
lesson, we should do
you
that.
can get all the X's. You can get all the first elements if you want. You can get all the second elements pretty easily if you want. It's just that transposing it, if you had the right thing, would have been a lot easier to do that.
Yeah.
What are we trying to test whether or not we can even plot anything right now? Because we
No, I'm just trying. I just want a quick thing to get all the first. Split these elements in half. So I want the first column and the second column.
Yeah, then just do like a list comprehension if that's what you want to do.
Oh, dude, I hate those things.
I mean, it's pretty easy. So just do it. Just start. I'll talk to you with it. All right. So can you just print
Okay.
out X? Can you just print out X so I can see it real quick?
Yeah. Yeah. Here's X.
All right. So let's make 2 variables. Let's call A and B or something. We'll say A. No, do it in the frame below it so we can.
Okay.
So
A equals.
yeah. Let's do like a list here.
Oh, I do like a 4.
Yeah, but you're gonna want. Yeah, but you put this inside of a list.
he could say just A equals I1 for I and
hold on,
X,
hold on.
and then B
Listen.
equals I2.
What? Okay, so just
He
do,
could-
just do
he could
I1,
say A-
Just do I1 for I in X, and then B is I2 for I in X. Okay, that's it. I index 1.
Say that again.
I index 1
Okay.
I in X. Okay.
Yeah.
And then do B equals I index 2 for I in X. Yeah. So there are better ways to do this, but this is just the brute, stupid way to do it. Okay. And then just check them.
I wonder. Okay, we'll see. Okay, that did work.
So this would have been a lot easier if each
So this just
was
pulls
its
the-
own
yeah.
nested thing.
So now you should be able to just plot A,
Plot
B.
comma B. Right. And I think by default it's gonna scatter.
Yeah, it should.
I guess there's a lot of elements, so maybe.
How many?
Yeah, I added like 100 to
Not
it.
that many.
I think by default on their site, it creates this
What is
All
graph.
right, just
What
do
is
scatter. I don't know
They use-
why it did that. Yeah, it does a line graph.
Yeah, it does a lot. Plot does lines.
Okay, so
By
try
default.
scatter.
We should just scatter A, B.
Yeah.
Should be fine.
Wait, let me do this. Maybe.
No, I don't. It's definitely.
No, it's not going to let
I
you.
don't think it's going
Well, it's
to,
definitely
but-
part of the plots package because I'm looking at it in my help menu.
Okay, there we go. So
Yeah, it works.
So it didn't recognize scatter because it didn't recognize a scatter that takes one argument.
That's what I was trying to say
Right,
before. You need an X and a Y. Yeah.
Yeah, let's try to.
Like it'll work. It just didn't recognize.
Yeah.
It's not like
So how do you think I color these?
What exactly do you want to color?
I want A and B to be. I want the points on the plot to be the color of the cluster. So I have X comma 5. So we have 5 clusters, and they're stored in assignment. So I got to do something else.
Assignments, to be real quick, because it's been a little bit. So assignments is 100. It's the length 100 for all of our X value for all of our. It is.
That's fine. That's fine. But
No, I want to
problem-
just make sure
he's
we
gonna
updated
have-
it or whatever.
Well, the problem, right? I mean, the problem he's gonna have. Yeah, you're gonna have to do assignments by index because you can't do it by anything else. On this case, because you separated them.
Well, they tell us how to color it, right?
Yeah, I see what he's saying. Like,
Well, that's normally how you visualize these the cluster. Like we have a perfect case where we have 2 dimensions.
Excellent.
We don't have 100 dimensions, so which means we can visualize it by color. And even if you had this in 3 dimensions, you could have a rotating thing.
On page, I don't know. So on page 37, right? They scatter and then they add to the scatter plot, and it looks like it colors the groups by default.
Yeah, I gotta practice these comprehensions because I'm not very good with them.
So
I think you
just
first.
like the exclamation part, mark when you add to the scatter. That's gonna color it.
That layers it. The exclamation.
Okay.
That layers it, and by default, layering with another scatter looks like it colors it. I don't see where else they're coloring it. Yeah.
Yeah, for.
Oh, sorry. Someone is at my door. I'll be right back.
Yo, can you scroll down to that? I want to see how they're doing it.
She walked out.
Wait, I have it shared on my screen, I think.
Yeah, I'm looking on your
Okay. So it looks like, they created their initial scatter plot, but they only scattered one of the groups. And then they, add a layer where they do another scatter plot for another group. And they add a layer and do another. And by default, I think that's what colors it.
Yeah.
Be a different color, but you can.
Yeah, it's gonna keep I put the scatter in already, but it's gonna keep that data
There's
point.
a way
I think
to
it's
do
just gonna.
what you're trying to do. Also.
Oh,
you
for
can add
sure.
but there's a
We
way
just
to
don't
do-
know it,
Yeah,
right?
yeah. I mean, this one's just literally they broke the groups apart and they scattered each one.
Yeah, and then they scattered them
That's all,
separately.
that's all that is. Yeah.
You
Oh, I'm not doing that. Fuck that. All right, you're done.
All right. I mean, it's yeah.
Yeah, but you get what I'm trying to do. I'm trying to just
No,
visualize.
It's a good idea.
Because the thing that they teach you when you go through like all these like clustering, all the different clustering algorithms, is like the main thing is like you're trying to replicate what the human eye can see. And the thing is, there's no substitute algorithm for what the human eye can see, but as you add more dimensions, it becomes impossible to visualize. So you have to use these algorithms. So like you could have data that looks like the universe. So it's like a spiral and it gets smaller and smaller as it goes in. And that's one where you have to use these eigenvalues to determine like to connect the ones that are in the spiral together. And also anything with like connections is an eigenvalue based one. Like you can end up with one big circle and one small circle you could have a big circle around the center, like if it looks like the universe, like it's circles, concentric circles. There's tons of different problems that you run into.
Yeah.
There's interestingly, there's a group argument for scatter. I was trying to figure out what it does or how to use it.
Yeah.
But, I mean, there's definitely a million ways to do
Mm.
all this stuff.
Yeah, I mean, yeah, and we could. I mean, they're doing. We could literally just copy what they're doing. Because they just wait. What's
No,
VCAT?
theirs is very easy to understand. They literally just ran a group comprehension, broke them apart, whatever. But I think Michael's not wrong. Like I feel like you should be able to pass a group like vector that just
Yeah.
like an assignment vector. It just seems like
It probably has to do with the marker. So like in most of these in most of these like graphing things, there's like a marker equals like something. There's like an argument.
Let's see if scatter. I did see an extra argument on scatter actually.
Yeah, it should be.
I tried to type in. That's fine.
Oh, wait a minute.
I tried to type in like scatter for like the plot library,
Yeah,
but I typed in scatter
So-
plot. And
Yeah, so I think. Oh, let's see. What is the fuck is that? So I think what you can do, Michael, I think you can just try to pass the exact same thing, but pass marker color as your assignments vector.
Yeah, that's what I'm trying to find.
And if you can't
It's-
do that, then you would just write a comprehension to change like red, green, blue, or whatever from.
Why do they?
You know what I'm saying?
yeah.
No. Just trust. You're already there. Like if you just type in scatter a comma b comma marker color equals assignments. Yeah, that's what I'm saying. Try that. That might not work because what it's looking for is a legitimate color symbol.
Yeah, so I might have to go through it and
No,
replace
assignments
for
is
each
not
assignment.
defined.
It's looking for a color. So you're saying it would need a mapping from the assignments to a color.
Right. But yeah, he doesn't. For some reason, his assignments vector isn't defined though.
I gotta go for a run because it is getting kind
Oh,
of.
you're right. It's not defined. That's
Yeah, can you
weird.
just?
So
Yeah, no problem. Can you just
It's not called assignments. It's called assignment.
Okay, so try that. Yeah.
boom.
I knew there was an easy way to do it. See how they're all they all like k-means is really good for like if you have like three. So like the example that I went through when I was learning k-means was in archaeological dig sites, and they had like they had areas in which which different items were found, and k-means is very good at like segmenting circles that are evenly sized, but it's not good at like unevenly sized problems.
Do we only have 3 colors here? 3
There's
groups?
5.
We have 1, 2, 3, 4, 5. I put in
Okay, I have a hard
K
time
equals 5.
seeing the colors on my screen here. So we did k equals 5.
Yeah.
Yeah, K equals 5 right there.
How
Are you
far did we
colorblind,
get,
or-
by the way, guys? How far did we get to the end, or are we just?
I think we did basically go to the end. This is basically what they did.
Well, yeah, we took their example, but we didn't.
We did it better.
I know. It looks clear, doesn't it?
Yeah.
Yeah. Interesting.
Yeah, I mean,
Yeah.
it did it. K-means did a very understanding job for like basically randomly scattered points,
Yeah.
without clusters.
For sure.
It,
Yeah. I think we made up our